Yeah, good morning and good evening, everyone. Welcome back. So yesterday we started with monitoring, especially log monitoring. So first, we need to understand the concept. Low-level implementation is always secondary. Okay, first understanding and convincing to the concept is the primary and priority one, and it is very important. So as we discussed yesterday, there will be two types of monitoring, like white box monitoring and black box monitoring. White box monitoring is the one the employee setup, like the project employee setup. We know everything, what is in the project background, how many servers, how many databases, the connections, everything we know, the logs, everything. So that is white box monitoring. And black box monitoring is we don't know anything about the system. We just know the URL. So you can continuously hit the URL so that when it goes down, you can get the alert. Okay, so that is another type of black box monitoring, like as an end user. Okay, and we will set up a dashboard. So where everything, the graphs and the behavior of the system, we can watch it with the time. Okay, so alerting and root cause analysis, that is fine. And the latency is the one we have to measure at all the point of times, because we should understand how our system is responding. If it is responding very slowly, we should find that. And then traffic, we should always see the traffic also, how many users are accessing our system, and errors. We should always check the errors, like 400, 500 errors, why they are getting. And then saturation, are our servers capable of handling the traffic? We need to check this one as well. So these are the four points you should always remember while monitoring: latency, traffic, errors, and saturation. Okay, so for the first 3 points, like latency, traffic, and errors, we can use ELK as a log monitoring tool, so that we will get a lot of metrics. Okay, so the concept is very simple. You can have any number of servers, okay, any number of Linux servers. So what we do is we will install an agent called filebeat. Okay, so this filebeat can access that location of the log file, and it will continuously ship those log files to the log stash, where we can have some filters. Okay, so this log stash, the primary purpose of log stash is to convert the unstructured data into the structured data, so that we can query on the data. Okay, so on the unstructured data, you cannot query, just like your files. So you have some random text in the files. For example, I have this content. Can I query this content? No, because it is not structured. But if you make it structured, like into SQL tables, then you can obviously query it. So similarly, so this log stash can convert the unstructured data into the structured data. Okay, so this filebeat will send the logs to the log stash, and where we apply some filters, and log stash will apply that filters and output the data into the Elasticsearch. Okay, and then in Kibana UI, we can watch the data, we can see the dashboards, we can see the graphs, everything. So this is the whole concept. So for that purpose, what I'm doing here is I just created one ELK server in our RoboShop network itself. Okay, so I applied just RoboShop infra user. Okay, and then this entire system is created. Let us see that now. I applied half an hour back. Web.joindevops.online is up and running. Yeah, it is already up and running. Now we need to monitor this. So what I'm going to do here is, so in our web server, I'll install filebeat. Okay, and I took one instance, that is ELK. I named it as, and then this is t3.log. Here I will install all the components: Elasticsearch, Logstash, and Kibana. Okay. So this is the ELK instance. So here I'm going to install our softwares like Elasticsearch, Logstash, and Kibana. Okay. So the installation procedure, yesterday we already did that. Okay, but anyhow, you can see once again. Just add the repo. Before that, let us install Java. Okay, so what can I do is I can install everything at a time so that we can save some time. Okay. Yum install Java 11 Elasticsearch log stash of Kibana and then log stash. Okay, it may take few minutes. So meantime, we can prepare our log stash filter. So yesterday we got an error, right? So that we can prepare that now. This is the sample. So there is grok is the filter, grok pattern generator, and then here this is the sample. Okay. I tried yesterday after the class. Just keep it. Okay, let us understand this now. So grok pattern, the logstash syntax is simple. Here it will start with percentile, not dollar, percentile, and then braces. So this is the IP address. I want to give the key as client. Okay, so this key is your wish. Client, you can give IP address, you can give whatever you want, and there is a space. Okay, and percentile, braces. This is HTTP date, and I want to give it as timestamp. Okay, and then we have space and percentile. If you don't know what is that, then you can simply give word, and then this is HTTP method. Okay, space percentile, and this one is URI path you can give, and you can say HTTP underscore path. Okay, and then space. So this is word. I don't know what is that HTTP. You can just give word. Word. And this one I don't want to save it, or you can give it like HTTP itself. It's our wish. You can give or you don't give. I don't want this field actually. HTTP /1.1. It is not at all useful for me. And then slash, and then this one. So this is percentile again. This slash braces, and this is number. You can give it as HTTP version. Okay, so this one can just convert into float since it has the points, and then space percentile brace, and this is again number. This is HTTP status. Okay, close. This one we can just call it as integer. Okay, there will be no points here. It will be like 200, 204, 300, 399, 400, 404, 500, 503, like that. And then space percentile. So this is number again. And this is, we can call it as duration, and we can convert it into float. Okay, float is nothing but decimals, like 1.2, 2.3, like that. Okay, so this is the whole pattern. So if you get this line in the log file, then logstash is going to convert like this, and then it can send it to your Elasticsearch. So this is the structured data. Okay, this is the JSON query. You know how can we query JSON? We are already querying YAML, right? So this one we can easily do some analysis on this data. Okay, so let's save this pattern. This is the pattern, and then this is the sample. For this sample, okay, so this is the ELK server. It is already installed. First, we need to configure one by one. Okay, so I'll just save this to our latest today's notes. Okay, so now Elasticsearch. So it is already in VIM etc Elasticsearch / Elasticsearch dot YML. Okay, so this is the configuration file. So I'm going here, and then we already noted what to edit here. HTTP port, network host, and then you have to enter this line, discovery type single node. So network host. This is 0.0.0. And then HTTP port, uncomment this. And then just have an entry here. Discovery type is this one. Okay. Yeah, that's all. Now we can simply restart. If it is started successfully, so we can get the output. Okay, then it is started successfully. Similarly, let's configure Kibana. And comment this server port, server host. And here, Elastic hosts. Okay, that's it. Systemctl restart Kibana. So it will take some time generally to come up. Netstat -lntp. Okay. So meantime, let us configure our logstash. Okay. So logstash already installed. Just create a configuration file here. So this is where in conf.t generally we can give the logstash input, output, and filter configuration. Okay. So this is the input and output. So let us work with input and output. Later we can go for filter. Kibana is coming up. You can just check 5601. So Kibana and Elasticsearch both are connected successfully. Now let us restart Logstash also. Systemctl restart Logstash. Okay, no need to configure the Logstash because it was all default timings it has, default configurations it has. Okay, so let us enable all the softwares. Elasticsearch. Okay. Y601 and then Logstash is trying to come up. Okay. Yeah, 5044 Logstash is up. So RealK stack is up. Okay. So it is ready now to take the logs. So now let us install. So I want to monitor logs of any instance. You can take any instance, but for now, let us take web instance as a perfect example, because this is where the entire traffic is storing. Okay. So in our web instance, we have already Nginx running. Okay. First, let me stop Nginx. Systemctl stop Nginx. Let us go to the configuration. Okay, so this is the one. So we don't want few fields and we want some new fields. Okay. So this is the IP address and we don't want this one, remote user, and we want this time and then request. So this is the request actually. And here it is status. And we don't want the number of bytes sent. After status, we don't want any of these things. Okay. We want request time. How much time it took to send the response. 1, 2, and this one is all considered as remote address, time local, request, status, 3, 4, 5 fields. Okay, so this is the request. This is the whole request. Okay, request method, URL, and the HTTP version. And then this is the status and this is the duration. Okay, just have these lines. You can have all lines also, not a problem, but you don't need to store unnecessary things. Okay. And here you need to give semicolon, otherwise so this will not work. Okay. So now let us check systemctl restart Nginx. Okay. Let us go and check the logs, var log Nginx and then access log. Okay, you can see The logs are already coming in our expected format. So this is ready. We formatted the logs. Okay, we can just note down this. This is the one we are giving. Okay. And Nginx log format. So now let us install FileBit. Systemctl, sorry. We need to create the repo here. First thing. Create the repo. The content yum install FileBit. Shit. Locked. Okay, yum install FileBit. The FileBit is installed successfully. Now let us configure vim etc FileBit and then FileBit.aml. Okay. You can just give here input should be enabled true, and then here which log we are trying to access. This is var log nginx slash access.log. Okay. And we are not sending to the elastic. Okay, and comment this. Sorry, comment this. We are sending to the log stash. And take the hosts. Okay, so this is not local host. So this is different. This is our IP address. Okay. Yeah, so I provision ELK in default VPC, but fine security group is allowing everything. So in that case, if it is different network, you should always take public IP. So while you are practicing, just provision ELK in RoboShop network only so that it will be easy. So this is the log stash. Yeah, that's all. Okay. So everything is done. We changed the Nginx log format. We configured FileBit. So now let us start FileBit. Systemctl start FileBit. When you start, it will go and immediately try to push those logs to log stash. Okay, let us see that. Tail-f var log messages. Okay. Connection established to the log stash. Let us generate some log. Okay. So when you are browsing, it is generating a lot of logs in the background. Okay. It says it is pushing. If file bit is pushing to the log stash, so then log stash should send it to the Elasticsearch so that you can view in the stack management and then here index management. Okay, we are getting the logs. You can see we got 192 counts. Okay. This is the data. Now we need to create the index to watch it. Just go to Kibana index patterns. The data is available. Now, if you want to access through Kibana, you need to create an index. So index, I'm just searching, this is the one, and take the timestamp, create index pattern. Okay, index pattern is created and go to the discover here. Here you can search file bit, and then you can see we are getting a lot of data, and we can check here our message. Okay, so this is the message we are sending. So now this is completely unstructured. I want to make it into the structured format like this. Okay, so like this. This is the key, this is the value. So for that purpose, you need to have this one. So this is the filter. Okay, so let us take that filter. Grok filter. Okay, and can just go to Grok filter. Here we can see this. This is the filter. Just copy it somewhere. And then this pattern, I want to replace with this. Okay. Yeah, this is the filter. So I will add here. Okay, Grok, and this is the matching pattern. So now, yeah. So I'll stop file bit for the time being. Systemctl stop file bit. Okay, it stops sending. Now I'll go and apply this filters here. Okay, so this is the this is the filter, and then yeah. Okay, now let us start file bit. And generate some log here. Background, anyhow, a lot of requests are going on. Okay, I generated some log. Now let us see tail -f var log stash plain.log. Okay, so as of now, no errors here. Let us check. $464. So here you can see that our data is coming or not. The filter is not applied. This is very complex to check when something goes wrong in Logstash. What are the mistakes we did? Add log nginx access.log. Somebody is accessing. Somebody is generating the data. Maybe one of us. Anything wrong here in the pattern? Yesterday I tried, it was success, but maybe we need to restart the Logstash systemctl restart Logstash. We didn't restart, I think. That is also a problem. That should be the problem actually. Let us see that. Yeah, generated some log. And let's go here. Still no luck. So there is some error here. There is some error in our syntax. Okay. There is some error. So this is causing the error generally. So what I do here is I will take out this one temporarily. So let us use this pattern. Systemctl stop Logstash. Okay, stopping Logstash. And then here systemctl stop file beat. Okay. And then here systemctl stop nginx. I'm opening the nginx configuration. So this request is causing some error. So let us suppress this. Systemctl restart nginx. Let us check the log again. Okay, that is good. And then in our logstash configuration, so this is the pattern I'm going to apply. Okay, we can spend some time and understand, but don't want to spend too much time on this. One, two, three, four fields, fine. Systemctl restart logstash. Okay, let us check the logs. This should be the previous log. Don't have HTTP method anyhow. Expected one of the tab space new line number 9. Mistake I'm doing somewhere. Okay. Oh yeah. So this one match message is missing here. Someone, thank you. I think the previous syntax is also correct, but anyhow, we already edited. Again, stopping. Thank you, Sanjit, Srikonda, and Silas. To find out the error. I think now it is correct. Let us restart and then check the logs. No error now. It is good. Yeah, it is started. Thank you so much. And let us restart our file bit. And then let us generate some log here. us check. And now you can see, so we got the fields. So all this time I'm trying for this. So I want some fields like this: client, and then duration, and what is the HTTP status. Okay? So these things I want. So now once you have the data ready, so now you have the data ready in a structured format. Now we can have some dashboards and graphs on this data. Okay, we don't need to do any Elasticsearch restart because we are working with. So just understand this flow when you have to do restart. So you want to change something on the file bit side. Okay, so then you stop the file bit, you do the changes and start it. That is fine. When you want to do some changes on the log stash side, okay, first you stop the log stash. Okay, so before stopping, you need to stop file bit also. So I am saying like this, you can directly change the configuration here and then you can do restart. But to understand the flow, so what I'm telling here is, if you want to do some changes in the log stash, okay, so file bit is continuously sending it. If this log stash is stopped, then file bit will give an error, not able to reach log stash. Okay, just understand this for troubleshooting purpose. File bit is sending to log stash. If you want to do some changes on the log stash, then first, which one I have to stop? Either file bit or log stash. Can someone please send in the chat? Yeah, first stop file bit. Otherwise, you will get errors. Then stop log stash. Do the changes in log stash. Restart log stash. Okay, so now log stash is fine. Now you can start file bit. So this is useful at the time of troubleshooting. Okay. Previous syntax is also correct. There's something I was missing. Yeah. So now, so we have huge data here. Okay, around 968 hits. Now I want to create some visualization. Okay, go here, menu, and there is visualization library. So if you have the data ready, then use visualization is very simple. It is all about selecting the x-axis and y-axis. Create visualization. We are going to visualize the lens. Okay, here first, what are the four things we need to do? Latency, traffic, duration, and saturation. So these are the four things. Okay, let us work on it one by one. First, let's take latency. So on this horizontal, this is x-axis. Go to this x-axis. X-axis is always timestamp. Okay. And every 1 minute I want. So x-axis is always time. So I selected time. Now y-axis. What I want here? Latency. Latency is nothing but the duration. So in a 1 minute, I want to have the average duration of this one. Okay, you can give this latency. Okay. Close and save. So this is latency. Okay. Add to dashboard. So you need to create the dashboard. So I'm checking. Add to dashboard is okay, or else okay. This one, add to dashboard. I want to create new dashboard. Save and go to dashboard. Okay, so this is the dashboard. Just click on save. So this is RoboShop dashboard. Save it. Okay, so I created graph and then I saved it. Now you can see the latency is 0.01 in this minute. And now let us go to the visualization library again. I want to create this is the next one, traffic. Traffic is nothing but how many hits. Okay, you can select here. I'm going to select the area. We can select different types of chats. Okay, donut, pie, something like this. Okay, I want to select area chats like this. Here you can see the example. And then add timestamp. This is x-axis is always timestamp. You can check how much time you want. Every 1 minute I want. So this is the time. Close. Y-axis, which field I'm working on? Traffic. Traffic is nothing but count of records. Okay, for every one traffic, we are getting one record. So if you calculate the number of records, that is the traffic. You can see at this minute, the traffic is 450. And so this we can say traffic. Close. Okay, now you can see overall traffic we have is 604 in last 15 minutes. Okay. Here you can check the timing also, the graph timing. So here it is last 15 minutes. That's it. Now you can save. So this is traffic dashboard, existing RoboShop, save and save here. Okay. Traffic is done. Now let us go to visualization again and create another visualization. What is it? Duration. Sorry, this is errors. Latency is nothing but duration. This is errors. I can check area chat, x-axis, timestamp, customize every 1 minute I want. Time, y-axis is errors. So count of, check add advanced options, filter by. So we have our HTTP status. HTTP status greater than 399. Okay, it means like from 400, 404, 500, 504, something like that. So everything is an error, either client side error or server side error. Okay. Enter. That's it. Just click somewhere out. So now I'm counting the records which has the HTTP status greater than 399. That starts from 400. Now you can see we got 12 errors. Okay, and no errors now. Let us again save errors, existing RoboShop, save. Okay. Yeah. So now you can see the latency is a little bit increased at this minute. So now I want to generate the load on this website. Okay, we have a simple, lab auto command. Just run this command lab auto. And here, if you see, there is RoboShop load generation. This give 49. Can do it from any public server. Okay. It will reflect like multiple persons are accessing our website. Or you guys are also can generate some load. This web.joindevops.online. How is it taking time? Okay, I can give the front end IP address web.joindevops.online, port number 80. I want 100 clients at a time accessing our website for 2 minutes. So 100 users are accessing our website at a time. Wrong time format. Can need to give 2M. It's fine. Yes, yes, yes. 2M. That is the Docker image in the background. It's fine, just a load generation tool. So now a lot of persons are accessing our website. Now we can see the traffic and then latency is increased 0.036 seconds. And now 342 and errors are like 33 errors. You can always refresh and then see. Latency decreased. Traffic is increasing. I think 2 minutes is over. At this particular time, the latency is 2.18. So it means when too many clients are accessing our website, the latency is increased. Okay. Yeah, so this is how you can have the visualization. So on for the fourth point, we need to learn Prometheus. Okay, so this is about the server metrics. So like inside the servers, how much RAM is consuming, how much CPU is consuming, how much disk free. So that is for that. For example, here out of 8 GB RAM, we used 5.7, 3.2 GB RAM is free. And we need to check continuously the disk space and the CPU utilization. Okay, now the CPU consumption is 1.19% on average. So like that, you have to measure these percentages and then always alert someone. Okay. So but I felt the monitoring at this point of time is becoming some heavy to us. So what I can do is I'll stop with the ELK here and then Prometheus, we can have it later. Okay. So we'll back to our flow like Terraform and then creating infrastructure. So you practice till ELK, okay, ELK monitoring, and then later we can continue this Prometheus monitoring and alerting mechanism. So once we complete AWS and Terraform part. Okay. So the next thing we can discuss today is, yeah, we need to make our infrastructure ready anyhow. So we are not at the good shape. So if you see this RoboShop infra, till this time we are just taking the lenience of allowing all. But in real time, we should not do that. Okay, so this is the infrastructure, right? So everywhere you need to have security groups and you need to have proper firewalls. But till now we are using allow all security group, and then we are accessing with the public IP address. That is not the good approach. So the good approach is like our office network. VPN. So generally, if this is our office network, like this is our AWS account. So here we have all the servers. What we have generally is we have a VPN. So we will connect to VPN before accessing office environment. So all of us will connect to VPN first. Okay. From this VPN, it will connect to our office network, right? So this is our AWS account. This is VPN. Okay, you should not have direct access to your infrastructure. Okay. We are doing all the same way. First we connect to the VPN and then we can access our office network. So VPN, we will discuss that later. But for now, I'll reflect one similar kind of VPN environment. So that is nothing but, okay, we will install anyhow VPN, one open VPN. So this is the default network. So we need to discuss another topic before that. This is the default network, default VPC, for example. Okay. And this is RoboShop VPC. Okay. So I will create one server here. This is public, inside public subnet. Okay. So this I will call it as VPN. Okay, we will install VPN software also. Our user will connect to this VPN server. Like employees will connect to VPN server. From here, we will access our all web tier and then database tier, whatever we have. Web tier. App tier and database tier. From this VPN server, we will connect. Okay. So we should have a dedicated VPC, virtual private cloud, for our RoboShop, and we will use default VPC for the VPN. Okay, VPN is nothing but you can call it as Bastion host generally. So these are all the private infrastructure. To connect to this, I should have the connection between two VPC. For example, you are in one home network. You have your home internet connection. I have my home internet connection. I cannot connect to your laptop directly. There should be some configuration between our two networks. Okay, so that is called peering. So this is network 1. So this is network 2. The VPC peering is very important concept. So if you want to allow communication between these two networks, you should do some peering. Okay. So by default, any two networks will not allow traffic of another network. Suppose network 2 by default cannot allow the traffic of network 1. So network 1 cannot allow the traffic from network 2. So this is the basic network security for all of us. Okay, just like your home also. I cannot connect to your home network directly. I cannot hack it. So there should be a peering connection between them. So in AWS also we have a concept called VPC peering. Okay. So now as discussed, I will create RoboShop VPC and then I don't allow the direct communication. I will create one VPN server in default VPC. From here, I will allow the connections between these two. Okay. So now let us just understand that peering. So this is very important concept. First, I'll destroy these instances. Okay, focus today. It's very important. VPC peering. Okay. Create VPC. I'm creating one VPC like VPC1. 10.0.0.0/16. Okay, this is VPC1. And I'm creating VPC2. This is 10.1.0.0/16. Okay, so the condition of pairing is only one condition. Your CIDR should not overlap. Okay, so this network is different. This network is different. If you have the same CIDR, CIDR here, then peering will not work. Remember this point, CIDR should not overlap. Okay, so the IP address here you will get 10.0. The IP address here you will get is 10.1. So both are not overlapped. Different CIDR. This is the condition. Okay, subnets. Do we have subnets? Okay, I'm creating subnet. For VPC1, let me create one public subnet. Okay, 10.0.1.0/24. Okay. Let us take East 1A. VPC1 public. Okay, create subnet. And then I'll create VPC2 public. VPC2 and VPC2 public. Take it 1A. 10.1.1.0/24. Okay, create subnet. So VPC1 public, VPC2 public are created. So now internet gateway. VPC1 internet gateway. and attach to VPC1 and create internet gateway for VPC2 and attach to VPC2. Second, let me delete this LK instance also. Okay, so what I did, I created VPC1, I created VPC2, I created public subnet VPC1, I created public subnet VPC2, I created internet gateways and attached. Okay. So now let me create one instance. Like VPC1 instance. Okay. Let's take our REMI and then prepared known. If we don't have any existing security group, so select VPC1. VPC1. This is in VPC1 mission and then VPC1 public, allow IP address and here create new security group. I'm giving it as allow all VPC1. Okay, and add security group rule, all TCP anywhere, and then launch instance. Okay, so we have to do one more thing. We created public subnet, but we need to attach the route. What is the route table? So here, for every VPC, there will be one route table. Okay, you can see this is the VPC1, and this in this route table, you need to have route to the internet. Okay, similarly, another route table for our VPC2. Here you should have route to the internet. You should understand this flow generally. Subnets, if you go and then check the route table, here you have internet route. Public subnet here, and then add the route of internet gateway to the route tables. Okay, so anytime creation of VPC is nothing but VPC subnets internet gateway internet gateway and association to the VPC and add the routes to the route table. Okay, if you don't have routes, you cannot connect. Okay, so we have added routes. Now let us try to connect to our EC2 instance. This is our instance. Yeah, this. Okay, this is VPC 1. Status checks still initializing. Okay, DevOps 321. Okay, similarly, I will create another instance. VPC2 DevOps practice. Just try to understand what I'm doing. Yeah. Keep it. No. The network. This should be in VPC2 network. And give the public subnet. Enable the IP address. And create new security group. Allow all VPC2. Okay. I'm allowing all traffic. Add one more rule. All TCP. Anywhere. Okay. That's it. Launch. VPC2 is in pending state. So when I'm connecting to this instance, so understand what will happen. The network connecting to instance. Okay. I'm giving one IP address. First, from my modem, it will reach AWS data center. Okay. So I gave the IP address. It will reach the VPC anyhow. And VPC should have internet gateway. Okay. Otherwise, our request will not reach. VPC should have internet gateway. So it will go to the VPC level. And from VPC, it has to reach our instance, right? So then it will find out the subnet. For that subnet, route should be there from internet gateway. Okay, let us just visualize this. This is the modem. From here, the traffic will go to VPC. Provided if it has internet gateway. VPC should have the internet gateway. The traffic will go from internet gateway through VPC. And here there is subnet. That public or private. Yeah, there is subnet here. To reach from VPC to subnet, then there will be route. Yeah, there should be route. If you have route, then only the traffic will come from here to here. So this is the route table. So this route table should be attached to the public subnet, and it has route from the internet. So you need to practice this again and again. So from the route table, it will come through the internet, EC2 instance. Okay, if you are not able to connect to EC2 instance, you should always check either VPC is attached to the internet gateway. If it is attached, okay, request came here. And from here to route the request, your subnet should have the route from the internet. Okay, this is just like a road. A road is there between from my modem to the Amazon Internet Gateway. And a road should be there from Internet Gateway to your subnet route table. If you don't have this route, obviously the request cannot reach. Okay, that is the simple thing. And now we have VPC2 also running. Let us connect this one VPC1. This is VPC1. And now this is VPC2. So let us check whether I'm able to connect to VPC2. Let me take the VPC2 IP address, obviously public IP, telnet on port number 22. I think because of public, sorry. So control plus bracket. Okay. Yeah. So let me try to connect to the private IP. So public obviously will connect because we allowed everything. Private IP port number 22. So there is no private connection, but we want private connection. Okay. Obviously, I'm going to suppress public later. Okay. I want to connect to the VPC2 on private IP address, not public. Public, obviously, we can connect because we allowed everything. So there is no communication between these two. There is no communication between these two. Now we need to enable peering. The peering is go to VPC, and then we have, there is something called VPC peering. Peering connections. Okay. So create peering connection. Now, for example, VPC1 is requesting. VPC2 should accept the connection. Okay, I'm sending a request for VPC2 to accept the peering. Okay. VPC peering. I'm just giving us VPC peering. Select a local VPC to peer with. I'm going to peer with VPC2. VPC1 is requesting and acceptance should be VPC2. Okay, VPC1 is the requester, VPC2 is the acceptor. You can choose anything. VPC2 is the requester or VPC1 is the acceptor, anything. Okay, so I'm creating the peering connection. So you need to accept. Here there is an actions, accept. Okay, peering connection is accepted now. So there is a peering running between two VPCs. Okay, but you should have the route also. Just creating peering connection is not enough. You should have the route also. How can we have the route? So inside route tables, okay, in VPC1 route table, here edit routes, add route. So this is VPC1, right? VPC1 should add the route. I'll just say should add the route to the VPC2 through peering connection. So this is the one. So what is the VPC2 CIDR? That is 10.1.0.0/16. Yeah, so this CIDR, I want to lay a road that is through the peering connection. Okay. And similarly, you should have the road from VPC2 route table also. VPC2, edit routes. So this is VPC2. Just VPC2 should add the road to the VPC1 through peering connection. Okay, so what is the VPC1 CIDR 10.0.0.0/16? And check the VPC for peering. Okay, so I created peering connection and then I added them as a route. Now a request will go from here to this network. So that is through the route. Okay, now let us try telnet 22. Now you can see it is connected through the private network. So then now the traffic will not go out. If you select public IP address, if you give public IP address, now what will happen? So if you want to come out of telnet, control plus and then right side brace. Okay. Control plus and this right side brace. Then you will come out and then press Q. So if I select public IP, so now how the traffic is going on here is traffic will come out from the AWS and then it will come and then reach like this. I mean, what can I say? This is the network one, this is the network two. If you use public subnet, then the traffic will come through. So here VPC will have one modem, right? This is the internet gateway and this is the internet gateway. And this will go out like this. Traffic will come like this. So it is coming out of the AWS infrastructure. it is not secure, okay, and latency will increase because it is going out of the AWS and coming inside the AWS again. If you do the from public, and that is not secure also. If your data is going out of your network, anybody can hack it. Okay, anybody can do wiretapping also in the worst case. Okay, so they can access the internet wires and they can fetch the data, generally in the worst case. So this is not good. This is not at all good. Accessing to the public IP address. Not only good for security, and it is also not good for latency, because latency will definitely increase if you connect through the public IP address, and then the cost also will increase. Okay, AWS will charge if the traffic will go out from the AWS infrastructure. So we will achieve the private connection between two networks through the VPC peering, and we will have strict security groups. Okay, I will not allow all security group. So this is what I'm going to do. So we have default VPC in every region. So I'll create one instance. I can make it as VPN instance. If I want to access like port number 22 on these servers, first I need to connect to this VPN. And from here, I need to connect to the servers. So this is what we are going to do in our next session. So VPC pairing, I did manually right now. And then in tomorrow's session, we will do it through the Terraform. So we are going to achieve this one, all private. So nobody can access our system apart from authorized users. Okay, so you practice today VPC connection, and then try to achieve it from the private IP address and understand at each and every point how the request is going. So I have the route so that it will not go out. Yeah, we can have a few questions. Santosh Avula.
Hi Shiva, good morning.
Yeah, hi, good morning.
Yeah, Shiva, VPC pairing is done in say within account, right? Suppose in our organization multiple accounts are there.
Yeah, so
how to achieve that thing?
Yeah, you can do anything. So only condition is this one. So there is one condition. VPC CIDR should not overlap. Okay. So this is one condition. And you can do the pairing between different accounts. For example, from my account, from your account, we can have pairing between two VPCs. Okay, you have one VPC in your account. I have one VPC in my account. We can have pairing between both of us.
Okay, you have to follow the same conditions?
Yeah, same. Just you need to give accounts. So here it is asking, right, when you are creating VPC pairing, it is asking account ID. Where is this? You create VPC. So I'll name it and then I'll select my VPC. And you can see I can have another account, or else I can have another region.
Okay.
Okay. So different VPC in same region. This is possible. Okay. Different VPC in different regions. This is possible. Different VPC in different account and different region is also possible. Okay, we both can have pairing. So everything is possible here. Only one condition, VPC CIDR should not overlap.
Okay, I have one more doubt.
Yes.
You have to VPC created time, you have to create the subnets, right? Yeah, meanwhile, automatically generated route tables, or we only created route tables?
So every time you create VPC, generally, there will be two things. One route table will be created automatically.
Respected VPC, right?
For any VPC you create, okay? For any VPC, it will create one route table automatically because it needs to have that local route, right? So for that purpose, see this one. This is the local route. Okay.
Okay.
So for this purpose, it will create one route table automatically whenever you create one VPC. And then it will create one security group also. One default security group. Okay, default VPC security group, default VPC security group. But it will not. Okay, so these are the default things happen generally.
Yeah, like tunneling also same, right, Shiva? You are doing right VPC peering and tunneling. One of the concept is there, right?
So tunneling is like SSH tunneling. So this is between the networks. That is, yeah, concept is same. Okay, so the tunneling is between two servers only.
Okay, that is like a on behalf of the security group, right? Tunneling.
So security group is nothing new actually. It is just a firewall service. So firewall service. Okay. So tunneling is like, you know, the tunnel, one side, one person, another side, another person. Nobody can enter into that. Okay. Yeah. Similarly, if two servers are connecting with each other, you can have tunnel between two servers. Okay, that concept is different. Now let us concentrate on this VPC peering only.
Okay. Yeah, thank you, Shiva.
Okay. Any other questions? Yashwant?
Hi, Shiva. Sorry, yeah. The last, after peering, like VPC1 is accessing VPC2 and VPC2, we are making it to accept the VPC1 traffic. So after that, traffic from public subnet also will it go or it will not go?
Now, if you have peering enabled, traffic will go privately.
Privately, okay.
So it is completely AWS network.
Okay. And now if VPC2 also need to communicate with VPC1, maybe there are some files, some servers they need to access.
Yeah,
then we need to both ways. Okay. Same way we need to add in VPC1 also.
Yes, correct? you must add. Otherwise, okay. See, if you add only in VPC1, traffic will reach to VPC2 server, but it will not come out again. It will not come back again.
Okay.
You understand?
Okay, so both ways we need to add the route. Both
yeah, ways. So you are laying a road. You are laying a road from your to other VPC. But similarly, from other side also, there should be a road.
Yeah, okay. Got it. Yeah. And one small thing, not like a critical one, for telnet stopping, can we do Control-C also, right?
Control-C will not work. No. So that should be Control plus. Plus means it's left side of the backspace, and then this one. Then you will be into telnet prompt. Here you need to press Q.
Yeah. Thank you, Shiva. Yeah, I'm good.
Srinu?
Yeah. Hi, Shiva. Good morning.
Yeah, hi. Good morning.
Regarding this monitoring, can we face the same situation in real time also, like configuring that grok patterns, all this?
Yes, you do the same.
Okay. There is no existing setup.
No existing setup. Actually, in Kibana, you have some open source graphs actually. Okay. So while discussing Prometheus and then Grafana. So we can access this Elasticsearch from Grafana also. So Kibana is one of the visualization. So and then similarly Grafana is also there. Grafana is also another visualization tool. So that is more easy than Kibana. From there also we can have some graphs.
Okay. Whenever we are deploying our infrastructure, we need to configure with our monitoring, right?
Yeah.
Yeah. Okay. Got it. Thank you, sir.
Okay. So any other questions? Kishore?
Yeah, good morning, Shiva.
Yeah, hi, good morning.
Yeah, actually, through the ELK, we can monitor our application logs. What are the requests we are getting? For that, for Prometheus Grafana also, we can do the same, or what we have to monitor?
Prometheus is for metrics. We already discussed it is for metrics, not for the logs. Prometheus is not for the logs. Prometheus is only for the metrics. Metrics means like how much RAM it is consuming, how much CPU is consuming, how many processes running, like that.
Yeah. For that application, what are the yeah? Okay. Regarding server monitoring.
Yes.
Okay. Thank you, Shiva.
Yeah. Arvind?
Yeah, Shiva, I have a couple of questions. First thing is ELK. So we can monitor at the application level only, right? From ELK.
Yeah.
So when we go on to Prometheus, we can monitor from the server level.
Correct.
Okay. The second question is, so why we need to have two VPCs? We can have only one VPC, right? So we created two VPCs.
Suppose RoboShop is a big project. Cart is in one VPC and then user is in another VPC. Okay, the team is different, everything is different. So Amazon.com is a big website, right? So we have India, we have all over the world. So all entire infrastructure we cannot keep in single VPC.
Okay,
so we will have different VPCs. Sometimes we will get some data from dev to production also. So dev and production, you cannot keep it in the same VPC.
Okay.
So, for that purpose, you should always have different VPCs generally.
Okay. Sure. Thank you.
So we are dealing with a simple project, but in real time, it will be very, very big, right? Banking. So it has a lot of components like credit card department, debit card department. You cannot keep the entire infrastructure in single VPC. That will become a big security problem. So we will have different VPCs and them connecting between all of the VPCs.
Okay. Thank you.
Yeah. So that's all for today. So tomorrow we will automate this with Terraform, and then we will proceed the same again, one more round of configuring our infrastructure. So while doing that, we will discuss a lot of AWS service and then we will automate with Terraform. Thank you so much. See you in tomorrow's session. Have a nice day. Bye-bye.